So now we're starting to get to the point where we actually can use Shiny in a way that would be helpful for us. And one of the main ways in which Shiny is useful is in creating interactive graphics. R, by default, doesn't have a lot of capacity for creating interactive graphics. Shiny really expands that capacity and gives you a nice way to disseminate your results because they're embedded in a web page that you could put out very broadly. So in this case, we're going to create an interactive plot. We're going to actually have a little bit more code in the server.r functions. And I think at this point, once you go through this example, you should hopefully be able to start using Shiny in a much more realistic way that would help you with your day-to-day data science needs. Okay, so let's get right to it. Okay, so I've copied the code from the R Markdown document. And let's just run it first and see the app before we start digging into its internals. So what it basically does is it plots two sets of random uniforms. So you input the number of uniforms and see this is a text box that also has an increment and decrement operator here on the buttons on the right-hand side. Okay, and then you have these sliders that can change the range of the uniforms that you generate, both on the x-axis and on the y-axis. Then you have these buttons that say show and hide the x-axis label, show and hide the y-axis label, show and hide the title. So we have these three checkboxes here, these two sliders, okay, and our numeric input right here. Okay, and notice how the code is executed interactively, right? Every time I change a value, it's rerun. The whole set of code is rerun. So that's something you're going to have to get used to with Shiny, is how to program with its server calculations and its reactive coding, which operates in my mind a little bit differently than standard highly linear R programming. Okay, so now let's go through the code and see how we accomplish this. So I think it's usually best to start out going through the UI.R function, the Shiny UI function. Okay, so title pane, we know about that. Okay, the numeric input, okay, it's labeling that input numeric, and then here's the title, and then it gives you the starting value, and then it gives you the minimum and the maximum, so you don't input values above or below that range. And then the step size for those little buttons, when you push those little buttons, how much it steps. Okay, then we have the two sliders. We've gone through the sliders before. Okay. All right, and notice these sliders, they're like double. It had the double slider. It had the two values. Okay, so you need the two values here and the two values here, so that you could have the slider at the two points. And then here's the Y slider, basically the same thing. And then here's our three check boxes. Okay, so notice just back to the sliders. Notice the first one was slider X. The second one was slider Y. And then these have very obvious labels: show X lab, show Y lab, show title. Okay. Then in the main panel, it's just going to show the graph, and it's going to do plot output of plot1. So it's somewhere in our server function we're going to have to have created something called plot1 that is going to get sent back to our user interface. Okay. Now in our server, okay, our Shiny server, it looks like it always does, has function input output, our curly braces because it's a function. And then output $plot1. Okay, this is good. This means that the output from our Shiny server is going to have something labeled plot1, so that when we display it with the user interface, there will be a plot1 there. And okay, because it's a plot, the statement is render plot. Okay, and then all of our reactive expressions, reactive means kind of interacting with the server, with server calculations. Okay, they're going to have this notation where they have the curly braces next to the parentheses from the render plot statement. So you've got to get used to writing these curly braces in reactive statements. Okay, so just get used to that code. Okay, so here we're just setting a random number seed. Okay, now we're just doing some regular R coding. The number of points, we're just relabeling the input $numeric, and that's just for convenience, so we don't have to actually refer to the input function to make our code look a little bit readable, and honestly for pedagogical purposes here, where I'm just showing you how you grab the numeric value from that numeric input. Okay, So the min for x, the max for x are the elements of the slider, and these come out as input is a list, and the slider x value is a vector, and so the first element of the vector is that minimum value. The second element of the vector is the larger value. Same thing for our two y points, and so we're going to do those. We're going to assign those all to variables, so because it would be a lot to type if we wanted to reuse those every time. Okay, and then our data, the list of random uniform numbers, is just going to be our unif. That just generates a bunch of random uniform numbers, and this takes in the number of points and the range between the min of the x and the max of the x. And then our data y, and that'll just return a vector of uniforms. Data y, number of points, okay, min of y, max of y, okay. The label, right, this is just an if-else statement. The input show xlab is the checkbox is either going to be true or false as to whether or not it's checked, and that's going to be in this label show xlab, because remember that's what we labeled that checkbox, okay? And then it's saying if that's true, in other words, if showing the label, then give the label x-axis. If not, give it nothing. Same thing with ylab. So these are two just R variables that are going to be the text that we're going to display in the plot. Okay, and the same thing with the title. So the title is going to be, if this is true, we're going to have the title labeled title. Otherwise, it's going to just be labeled nothing. Okay, and then we give our plot. We're going to plot our x data with our y data. Our x lab is going to be x lab, where that is defined as either x-axis or nothing. Y lab is going to be y lab, where that's either going to be defined y-axis or nothing. And the main, same thing with the main, is either going to be title or nothing. And then our x limit is going to be always set fixed at those values. That's why the plot is always in the same space. Y limit is always this, and then it'll return it. Okay, so that's it. Let's run it again now that we know what it's doing, and look at it again. So remember what it's doing. As we change a value, okay, it's taking this value, right? This is input for the server. This is going to be input slider x value 1, okay? This is going to be, yeah, that's the minimum. I think I said right earlier, but it should have been left. This is going to be slider x value 2, okay? This is going to be slider y value 1. This is going to be slider y value 2. This is going to be true or false for show x lab. This is going to be true or false for show y lab, okay? And so what's going on is, as we put in these values, the Shiny server is always checking for new things, and every time it's got a new set of values, it's rerunning everything and redisplaying it, going back and forth between the server and the UI, okay? So later on, we'll show you how to put in a done button in case your calculations going on in the back end are much weightier and you don't want to run them immediately upon receiving new values. Right now, this is such fast code, that doesn't matter. But later on, we'll show you how to put a done button. That will help, in these instances where when you click a button, it runs a gigantic Monte Carlo simulation or something like that. Okay, but this is a pretty nice, handy little interactive graphic. I mean, it's not doing anything very terribly meaningful, but I think you could extend this to your setting where it's actually doing something quite meaningful. Okay, so now your homework is go through this example, create a plot, maybe use some different kinds of inputs. Don't just use sliders and numeric inputs, try some other kinds of inputs, and create an interactive graphic, a simple interactive graphic in Shiny.